Hello everyone, my name is D. Shravanjyoti. I will be presenting a seminar on probability and stochastic process. My roll number is 24BQ1A0427. In this probability theory and stochastic process, my topic is random process. Random process is also known as the stochastic process. In this random process, I have to discuss these topics: definition, classification of random process, explanation of types, one problem, application of random process. I have to discuss first of all I have to discuss about the definition. Definition of random process. A random process, also known as a stochastic process. All of we have to know random process, also known as the stochastic process. In this random process is a collection of random variables that are indexed most commonly by time. I have to repeat this definition once again. A random process, also known as a stochastic process, is a collection of random variables that are indexed most commonly by time. Next one is, each outcome of the random process is a time varying function called a sample function or realization. Next one is, at any fixed point in time, the process's value is a random variable and a single sample function shows how the process evolves randomly over time. In this definition, we will mainly discuss about the random process definition. Random process is also known as a stochastic process, and it is a collection of random variables. We have to remember this collection of random variables is the random process. We have to remember this definition. Next one is classification of random variables. Classification of random variables. Random processes can be categorized based on their whether time and the amplitude of the random variables are continuous or discrete. Anyone. According, they are divided into four main types. First one is continuous random process, discrete random process, continuous random sequence. Last one is discrete random sequence. These are the classification of random processes. I will repeat again. First one is continuous random process, discrete random process, continuous random sequence. Fourth one is discrete random sequence. Next one is, we will discuss about these class types. We have to discuss step one by one. Continuous random process. See this definition. A random process is said to be continuous if both time and the variable are continuous for entire duration. In this type, the random variable can take any value within a continuous range for all moment of time. For example, this is like a fluctuation of noise voltage in an electrical circuit where both time and the amplitude vary continuously. See this diagram. We have this diagram. We have to clearly explain this diagram, continuous random process. Next one is discrete random process. In a discrete random process, the random variable takes discrete values but time is continuous. The random variable can switch only between certain fixed levels while time progresses continuously. For example, a digital signal that alternates between two discrete levels such as positive and a negative level but exists continuously in time. See this diagram. We have square type of this diagrams, discrete random process. Next one is continuous random sequence. A continuous random sequence occurs when a time is discrete but the random variable is continuous. In continuous random sequence, time was discrete but random variable is continuous. The random signal is defined as specific time intervals but its amplitude can be take any continuous values. It is represented as a set of random variables defined only for discrete sampling instances such as tk is equals to 0, 1, 2, and so on. We have infinity of numbers are there. This type is often used when sampling and continuous signal without quantizing its amplitude. Next one is discrete random sequence. In a discrete random sequence, both time and the random variable are discrete. The discrete is a sampled at discrete time intervals and the amplitude is also quantized into discrete levels. This process is commonly used to digital signal processing. In this discrete random process, we have commonly used for digital signal processing. We have to use this discrete random sequence. Next one is the amplitude may be represented using two levels or multiple quantized levels depending on the applications. Next one is it is often obtained by both sampling and the quantizing. These are the diagrams of a continuous random sequence and a discrete random sequence. See these diagrams by one. Next one is problem. We have to complete the definition of the random process. Next one is classification of random process. And next one is explanation of these four types of random process. We have to discuss these step by step. Next one is problem. Consider the random process x of t is equals to cos of omega naught t plus theta, where theta is uniformly distributed in the interval minus pi to pi. Check whether x of t is stationary or not. Stationary means in this stationary I have to take the problem about the random process. In this problem gives stationary. In this way I have to discuss the stationary random process. Stationary random process is the mainly main types many type of types. First one is primary stationary process. Second one is secondary stationary process. Third one is wide sense stationary process. Fourth one is jointly wide sense stationary process. Fifth one is strict sense stationary process. These are the types of stationary process. In this question we have to check whether x of t is stationary or not. Find the first and second moment of the process. In this means we have to discuss the primary and secondary stationary process. Given one is given x of t is equals to cos omega naught t plus theta, where theta is uniformly distributed. In this stationary process or not, we have to prove x of t is strict sense stationary process. Next one is expected of x of t is equals to constant, and mean value of random process is equals to constant. Third one is variance of x of t is equals to constant in minus pi comma pi. See this, we have to prove first mean of the random process. E of x of t is equals to integral minus infinity to infinity x of t f theta of t d theta. Formula for mean of random process. We have to substitute the x of t in this problem formula. X of t is equals to cos omega naught t plus theta, and f theta is the uniform distribution function. We have to discuss the problem. Uniform distribution formula was the 1 by beam. In this way we have to discuss this 1 by 2 pi formula, uniform distribution formula 1 by 2 pi. Substitute these formulas, and constants are common. We have to common this constants 1 by 2 pi and apply the integral cos omega naught t plus theta is the sin omega naught t plus theta. Limits are applied. Next one is we have to all these formulas we have to apply. We have to e of x of t is equals to 0. E of x of t is not constant. E of x of t is equals to 0. Next one is variance of x of t. E of x square of t. Formula was E of omega s square omega naught t plus theta. In this formula 1 by 2 E of 1 plus cos 2 omega naught t plus 2 theta. Integral minus pi to pi 1 by 2 pi d theta is equals to 1. E of 1 is equals to. Next one is E of cos 2 omega naught t plus 2 theta is equals to integral minus pi to pi cos 2 omega naught t plus 2 theta into 1 by 2 pi. 1 by 2 pi are take common. Integral cos 2 omega naught t plus 2 theta formula was sin 2 omega naught t plus 2 theta by 2. Apply the limits and answer was 0. E of x square of t is also a 0. And variance of x of t is equals to E of x square of t is minus E of x square of t whole square is equals to 1 by 2 minus 0 is equals to 1 by 2 is equals to constant. X of t is a strict sense stationary process. Next one is we have to prove the f theta is equals to 1 by theta is equals to 1 by pi minus 1 by pi 0 greater than theta greater than pi. E of x of t is equals to, we have all this stuff. N of t is not stationary process of this formula. We have see these applications of random process on based on electronic communication engineering, noise modeling and analysis. First application is noise modeling and analysis. In this random process is applied to use of the electronic and communication engineering. Noise modeling and analysis are mainly use of engineering, and signal processing, wireless communication systems, error analysis and detection, optimal filtering and estimation, network traffic modeling, data compression, antenna systems. First one is noise modeling and analysis. In this application we have to noise cancellation, all this stuff we have to use this application. Next one is signal processing. We have in this daily life we have mainly used this signal processing application. Next one is wireless communication of systems. All these people are mainly use this wireless communication systems. Wireless communication systems are mainly popular of this our world. All of people use this wireless communication systems. In this way we have to use these applications of this random process. Next one is error analysis and detection. Error analysis or detection are the mainly use of applications. Next one is optimal filtering and estimation. Next one is network traffic model. Network traffic modeling is the one of use of our applications. Next one is data compression, and final one is antenna system. Antenna system is mainly used of our satellite of all of this stuff. I have mainly briefly discussed about all of these definitions. First one is definition of random process. Definition of random process is also known as the stochastic process. Stochastic process is a collection of random variables that are indexed most commonly by time. Next one is classification of random variables. Random process. Classification of random process. Classification of random process, we have mainly 4 types of random process. First one is continuous random process, discrete random process, continuous random sequence, discrete random sequence. In this continuous random process we have mainly example of this continuous random process is the fluctuation of noise voltage in a electrical circuit where both time and the amplitude. In this continuous random process is said to be continuous if both time and the random variable means amplitude. Time and amplitude are both of continuous. Next one is discrete random process. Discrete random process example was a digital signal that alternates between two discrete levels. In this discrete random process, random variable takes discrete values but time is continuous. This means amplitude is discrete values but time is a continuous. Next one is continuous random sequence. Continuous random sequence, we have mainly this type of often sampling a continuous systems without quantizing its amplitude. Continuous random process is when time is discrete but the random, this means amplitude is continuous. Next one is discrete random sequence. In this discrete random sequence, both time and the random variables are discrete. Random variables means amplitude are discrete. Next one is problem mainly we have we have used the formula says E of x of t is equals to integral minus infinity to infinity x of t into f theta of d theta. Variance of x of t is equals to x square of t minus x of t whole square formula. In this way we have to prove this formula. Next one is applications. Applications is noise modeling and analysis. All these are the applications of random process. All of you, thank you all.